Today we're going to talk about a type or types of probability with mutually exclusive and overlapping events. So at the top we've defined some vocabulary words here for you. A compound event is an event made up of two or more simple events. Think of like a compound sentence. You're taking two simple sentences and you're joining them together. Mutually exclusive events that cannot both occur in the same trial, they're exclusive. They can't happen together. Overlapping events that have one or more outcomes in common. But let's talk about mutually exclusive first. So mutually exclusive is the probability that one or the other of several events will occur is found by summing the individual probabilities of the events. So the probability of A or B tells us to add. So when we see the word or in a word problem, or when they ask us to find the probability of this or that, remember you're adding. So things to remember, or means add. Okay. The other thing to remember, when we say PA or B, remember that notation is the union of. We're talking about all of those things, okay? So we can ask the same question using that union notation. So find the probability that a girl's favorite department store is Macy's or Nordstrom's. So find the probability that a girl's favorite department store is Macy's or Nordstrom's. So the first thing we have to look at is we have to look at Macy's. So the probability of Macy's. So we have 0.25. Then we see this word or, so we have to add the probability of Nordstrom's. .20. Now, we can't be Macy's and Nordstrom's. Those two stores are different. They're mutually exclusive. So we just add those things together and find that we have a probability of 45. Okay? A 45th and 100th chance, because that's the 100th decimal place. Find the probability that a girl's store is not JCPenney's. So if we're talking not JCPenney's, look at this word not, okay, then I'm going to look at JCPenney and I'm going to subtract it from this total here. So remember, not JCPenney is going to be the probability of JC prime, okay, or the complement of JC, so not JC. So I'm going to add all of those together. So we have 2, 4, 6, 8, and 5 plus 5 is 10. That's going to be 0.9. Okay, 90 out of 100, 90 100ths of a chance. Okay. When rolling a dice, what is the probability that the sum will be 4 or 5? This chart is very, very popular. I'll actually upload this chart so you can just have a hard copy to continuously look at for this unit. But this chart's very popular. So it takes a hot second to fill out, but they want us to add the columns and the rows together. So this would be 2, 3, 4, 5, 6, 7, 3, 4. Okay. Again, not terribly hard to produce, but I'll provide a hard copy for you. When rolling 2 dice, what is the probability that your sum will be 4 or 5? So when we look at the probability of 4, so here's where you have 4s. This is the sum. We're not looking at our rows and our column titles, but we're looking for the sum of 4. Well, there's 3. Okay, there's 3 sums of 4, But out of how many possibilities? 6 by 6 is a 36 grid. Again, we see this word or, so we add. And we're adding it to the sum of 5. So here we have 1, 2, 3, 4 sums of 5. So that's 5 out of 36. So 4 and 5, those can't be the same. 4 is its own number, 5 is its own number. That's what makes it mutually exclusive. So we'll add these up. We get 8 out of 36. But remember, these things can be simplified. So 4 can go in here twice. 4 can go in here 9 times. Right? 1, 2, 3, 4. Oh my gosh. I said 4 times, but I wrote 5 because I was talking about the number 5. Not a good look. Now my whiteout is out, or my whiteout's messed up. This is the time, y'all. Okay, let's count again. There are 1, 2, 3, 4 5s. There are 4 5s. 3 plus 4 is 7. And that can't be simplified because 7 is prime. Okay. There we go. What is the probability of picking a queen or an ace from a deck of cards? So this comes the time where we need to recognize what decks of cards look like. So quickly here, I'm going to pause my video and sort out some cards and then explain. Okay, thank you for letting me awkwardly pause there, but I pulled out a deck of cards. What I noticed earlier, some of us haven't played cards or played solitaire or know what these are. So we have 4 aces in a deck of cards. We have 4 queens in a deck of cards. Okay, you'll notice there's 4 types of cards here. Okay, those are called suits. So we have diamonds, hearts, clubs, and spades. So there's 4 suits, 4 aces, 4 queens, right? We do have red cards and black cards. Okay, your diamonds and hearts are red, clubs and spades are black. I think this time at home is a really good opportunity to play cards. Maybe ask your parents, grandparents, whoever you're stuck with to play some card games. Set up solitary or any other game of probability using cards. It'd be pretty awesome to be familiar with them. So the question asked, what is the probability of picking a queen or an ace? Well, we just talked, there are 4 queens in a deck of cards. We see this word or, so we add. There are 4 aces in a deck of cards. But then we didn't really talk about how many cards are in a deck of cards, okay? Excluding the jokers, there are 52, okay? So we'll use that total of 52 cards. So it's going to be 8 out of 52 when we total all that up. And this can be simplified. 4 can go into both of them. And so 2 out of 13 cards is the probability I can get one or the other. All right, that's mutually exclusive. Let's look at overlapping events now. Okay. Overlapping events, zoom back in. Overlapping events is the probability that non-mutually exclusive events A and B or both will occur. So we still see this word or. Okay, so again, reminder, or means to add. Okay, but what you really have to be careful of, now that we add, we always want to double check to see if there's overlap. This tends to be the #1 missed question on quizzes and tests because y'all forget to double check. You're moving a little bit too quickly. Okay? We have to double check for this both, okay, or both. Because if they both occur, we can't count it twice, okay? So we subtract it out to avoid counting twice, okay? Notice they use the union for or, okay, and the intersection for the overlap, where those things are occurring twice. So let's look at these examples here. So find the probability that a person will drink both. Well, if we're drinking both, remember that's an overlap. Okay, that's an intersection. So we see this word both. We're talking about this intersection here. Okay, so that's the intersection. So that number is 12. But we have to add each of these parts of our Venn diagram together to know what our total is, and that's 151. Finding the probability of A or B. So that's the union. So we talked about this in the last lesson. You're only going to add these numbers once. Okay? So when we add these numbers up once, we're going to get 725 out of 1,200. You only add them up once. You can't add them twice because then you're counting this 35 twice. Count each piece once. And that happens to simplify to 29 over 48. All right, let's look at some more examples. Find the probability of picking a king or a club in a deck of cards. So a king, there's 4 out of 52 in a deck of cards. We see this word or, so we get to add. And then it says a club. Well, remember a club is a type of suit. So remember we have clubs. Well, there's 13 cards in each suit. So we have 13 out of 52. Okay. So now we have to ask ourselves, is it possible to be a king and a club? If we flip through a deck of cards, is it possible to be a king and a club? Well, the answer is yes. There's one of them. I just found it here in my deck of cards. So we have to subtract the overlap. So we're going to subtract 1 out of 52. So that's going to give us 17 minus 1. So that's 16 out of 52, which is equal to 4 out of 13. All right, find the probability of picking a female or a person from Florida out of the committee members. Anytime you work with a table of values, you need to find the total of those values. So what I'm going to do is I'm going to fill in my table here, and I hope you tune into the next video for more examples on mutually exclusive and overlapping events.